Alright, so this problem that we're looking at here is a quadratic inequality, but really we dealt with these in general by doing polynomial inequalities. So what I want to remind you of when it comes to these problems is that these problems were a whole lot easier when they looked something like this, when they were factored. That's one of the things that made them a whole lot easier for us. So that should be our first step in this problem, is to try to factor it. So we need to say what multiplies to be negative 3 adds to be negative 2. So negative 3 and positive 1. Now the next thing I want to talk about here is, especially by this point in your reviewing and studying, you've probably seen where I've shown you a lot of shortcuts because of the fact that it's multiple choice. Now I want you to be really careful about taking shortcuts, that these shortcuts aren't really shortcuts in the sense of not doing good math. Everything I've shown you has been good logical reasoning. What I want you to avoid is taking shortcuts because something looks similar. Because you look at this and say, oh, I have a negative 3 and a 1. I see a negative 3 and a 1 right there. Let's call it good. That's not the case here. We got to remember why we factored this in the first place. We factored this in the first place because our 3 steps for solving any kind of inequality have been pretend like it's an equation, plot those solutions, figure out what gets shaded. Yeah, that could be helpful if I actually used vowels. Figure out what gets shaded. So that's our basic process here. So if we pretend like this guy's an equation, we got to remember that we need to, so let me do this off to the side just so that it doesn't follow in the same lines. So if we pretend like this is an equation, we have to remember that we need to set x minus 3 to be 0 and x plus 1 to be 0. So when I add 3 to each side, I actually get 3 and negative 1 is what's really going on here. So now as I plot those important values on the number line, and I'm going to use an open circle because we did not allow equality in the original problem, we then have to figure out what should be shaded, the left, the middle, the right, or some combination thereof. And we have a few different ways of doing this. One way we could do it is to say, I know what the graph of this thing looks like. This is a parabola that opens up because it's a quadratic and the lead coefficient's positive. So if I want to know when this thing is under the line, since it's less than, it's simply this. So that's one approach we could take. The other approach we could take is by test points and say, let me test x equals 0, which is there in the middle. In the first parenthesis, 0 minus 3 is negative. In the second parenthesis, 0 plus 1 is positive. A negative times a positive is a negative. Are negative numbers smaller than 0? Yes, they are. That's a true statement, so we should shade it. And then we alternate, yes, no, yes, no, yes, no. Since the middle is shaded yes, the outsides must be no's. And we could, of course, test that as well if we tested a point like x equals 5 off to the right here. 5 minus 3 is positive. 5 plus 1 is positive. A positive times a positive is a positive. Are positive numbers smaller than 0? No, so that shouldn't be shaded. So we should be seeing that the correct answer